What I wanted to do in this video is just run through a couple examples of solving by factoring. Now, I feel as though this is a technique that many students tend to skip over and try to not factor. For some of us, it's because of just finding the combination of numbers maybe too challenging, or you just might not have a clear understanding of how to factor. But what I'm going to show you on this page here, this set of 9 questions, is how each of these is just perfectly set up for our factoring technique. Our goal is to be able to factor by either using quadratic formula, which will work every single time if it's in standard form, or factoring by square rooting, which will only work when there is a single x term in the problem, like example number 5 here is perfect for square rooting, but it could also be solved by factoring. And then factoring is a technique that can be used for problems that are factorable. Once it's set equal to 0, we can then find the solutions by breaking it apart into the 2 smaller linear factors. So what I want to do is just run through these, and hopefully then you guys can kind of start seeing that, hey, this is actually a really good technique, and it's actually the most efficient for many problems, because our goal is to think about efficiency. What's the quickest way we can get these problems done? So whenever I see, for factoring, whenever I see a quadratic that has the a value equal to 1, the a value being this number right here, in front of the x squared, in front of the x squared, in front of the x squared, I'm always going to try factoring first. Like every single time I will try factoring first, because it is the most efficient if that a value is 1. And if it is an a value of 1, we try to find our combination of numbers and undo the distribution. We say we need to find 2 numbers that multiply, one second here, 2 numbers that multiply to a times c and add to b. That's what we need to find. So the a value is in front of the x squared, the c value is at the end, the b value is in the middle. And all you have to then do is, once you find that combination, is put it in the parentheses. So we have to undo our distribution. We put an x here and an x there. Now find 2 numbers that multiply to negative 40. Well, what are numbers that multiply to 40? 1 and 40, 2 and 20, 4 and 10. Let's see here, 5 and 8, 6 and 7 don't work. So that's my combination. So if you need to list that, do that. But then this combination has to add to negative 18. So 1 is positive, 1 is negative, right? It's going to be this. We have a negative 20 and a positive 2. That multiplies to negative 40, and it also adds. So what are my 2 solutions? Now that I've got linear factors, I can find the values of x that solve this equation, or the values of x that make it equal to 0. So I'm really setting my factors equal to 0 and solving it. But some of you off the top of your head are able just to look at this and say, oh, it's going to be 20. 20 minus 20 is 0. I solved it, right? Same thing with this one, x plus 2. I want to know what makes it 0. I just set it equal, subtract the 2, and I get x equals negative 2. But once again, some of you might just look at that and say, negative 2 plus 2 is 0, and you got your answer. So that's solving by factoring. And notice how efficient it was, how quick it was to be able to do that. And I'm talking through this problem. So that's factoring with the a value equal to 1. But there's also factoring using greatest common factor. That's always what we start with. We always start with GCF. But notice that factoring always has to be set equal to 0. So look at number 2. I'm going to move this 56x. 16x squared, I'm going to subtract it to the other side. Now what I do is I look at the 2 quantities that are here, and I say I'm going to try to solve by factoring. I can't square root it because there's 2 x's. You could use quadratic formula, but the numbers are pretty big, and it would become a little bit messy. But let's try to factor this. So if I were to, let's see here, factor out the greatest common factor, I'd look at a 16 and a 56 and I'd say, okay, well, what goes into both a 16 and a 56? What is the biggest number that would go into those? And that answer is 8. But they also share an x. So I'm going to take an 8x out. And when I do that, I'm left with 2x minus 7 equals 0. So now it's completely factored. And notice how it's broken up into the smaller pieces. So if I want to know what makes it equal to 0, I find what makes each individual piece equal to 0. So this one, if I plug a 0 in for x, this makes it 8 times 0, which is 0. For this one, some of you may look at that and be able to see that the answer is 7 halves when you multiply by 2 and take 7 away. But if you don't see it, then you set it equal to 0 and you solve it. Add the 7 and divide by 2. So that's solving using factoring, but the factoring technique is greatest common factor. Okay, let's look at number 3. Set it equal to 0. Always do that. 15x equals 0. Take out the GCF, 5x. We're left with an x minus 3. What are our two solutions according to my linear factors? X equals 0, and on this one, x equals 3. Why? Because those are the numbers that make it equal to 0. And I'm going to go through this next set a little bit quicker. Number in front is a 1. I break it up into my two sets of parentheses. Now remember, not every problem is factorable. On this worksheet, it will be because I'm trying to emphasize this technique, but not every problem is factorable. So you would have to use quadratic formula. So if I see a 1 in front, I jump to this technique because I think it's pretty efficient. Two numbers that multiply, a times c. Oh, two numbers that multiply, I'll write it down here, to negative 7 and add to negative 6. Some of you off the top of your head can find that. Others of you maybe need to write things out. But the two answers are negative 7 and positive 1 for the factors. If you leave it right there on a test, you are at a 2. Okay, thank you for factoring. Great job. But you did not solve anything. We need to solve it. So all we do is we look at this and say, okay, what two numbers make these equal to 0? My two answers are 7 and negative 1. Positive 7, negative 1. The next one here, number 5. Oh, for some reason that just moved. Move that a little bit. I'm going to drag it back up. Doesn't like the word document sometimes. Okay, so we got our two answers. Let me rewrite those, 7 and negative 1. The next one here, I need to find, notice the middle number is missing. That means the b value is 0. That's okay, we can still factor. This one is perfect for square rooting, but this is what's referred to as a difference of squares in factoring. But it's used the same technique we just did. A value is 1, parenthesis, parenthesis. I put an x and an x. Two numbers that multiply to negative 49, a times c. But the two numbers have to add to 0. Well, the only way to add to 0 is if it's the same number, but they are opposites, positive, negative. So positive 7, negative 7. What are my solutions? Negative 7, positive 7. Okay, next one here. I need two numbers that multiply to 1 and add to 2. Well, the only numbers that multiply to 1 are 1 and 1. And 1 plus 1 is also 2. So my solutions here are negative 1 and negative 1. It is okay to have the same answer twice. We call that a double fruit. When we're solving, a lot of times in this unit, we've said find the zeros or find the solutions or solve for x. An equivalent direction could be find the roots. That's one way of stating it, find the roots of the equation. Okay, almost done here, last three. Once again, go through these quickly. Two numbers that multiply to negative 1, but add to the middle number, which is 0. So that's 1 and negative 1. Two solutions, negative 1 and positive 1. Next one here, two numbers that multiply, a times c is negative 4, and it's got to add to b, which is negative 3. So what are my factors? It's going to be, let's see here, negative 4 and positive 1 would get us to that combination. So go through that process, find your two numbers, find your two solutions. Negative 1 and positive 4 would be our two answers. And the last one, a times c is 20. It's got to add to b, which is 9. Hopefully you guys see that it's 4 and also 5 are our two numbers. X plus 4, x plus 5 equals 0. Two solutions, negative 4, negative 5. Okay, so I wanted to go through a little review of solving by factoring. I know we spent time actually factoring and having videos on that last week, but this is really an important technique, and I've seen way too many students skip this method. It's a really good method for solving. Um, at this moment, if you don't want to try to solve the ones that look like this right now by factoring, using that box method, that's something we will continue to get better at as we go. But we've got quadratic formula, we've got factoring using GCF, we've got factoring using our two quantities here, and using the A times C added to B method. Square rooting is a great method too. So those are the things we have to be able to do on our tests. And I wanted to put this video together so that you guys had an opportunity to see it again, watch it one more time, and hopefully it's starting to click.